Hello, so this is a demo for KongTuke ClickFix activity which I found from malware traffic analysis.net blog. So what this is it's basically a fake CAPTCHA verification malware. What this does is when the attacker injects a fake CAPTCHA page into a legitimate but compromised website, a visitor attempts to verify themselves. Malicious JavaScript copies a cmd.exe command into the Windows clipboard. Once the user pastes and runs it, following on-screen instructions, the system is silently infected through a multi-stage payload delivery chain. So what my demo will show is a complete analysis of the real ClickFix activity. The PCAP files for this have been downloaded from here, from the malwareanalysis.net blog. All the PCAP files which are on which the analysis have been done through Wireshark are being downloaded by on this website. This will be linked in my blog as well, whose link I'll be providing in the description below. And also we'll be performing a small demonstration for the ClickFix activity by for which I've created a fake captcha website myself. The link for that captcha website is so it is already being uploaded to GitHub. You can also see this GitHub repository whose link I'll be providing in the description as well. So let's begin. So first we'll be checking the demo of the fake captcha website which I made. So here it is. This is the demo file. For downloading the demo file, you can just open the link from the GitHub link from my description. These are the steps how you will install it. First, we'll clone the directory in through your CMD terminal, and then we'll npm install command and node servers. So make sure you are using minimum Node.js version 18 or above for this fake captcha website to work. These are the rest of the steps for the website, and this is the file structure. All right, so we'll jump right into it. So when you're in the file, you don't need to do anything else. You just need to do start.bat. You have to run this as administrator since we are making a fake malware, basically simulation of a malware. What this batch file will do is it will show up a front end page, which I'll be showing in a few moments, and that front end is linked to the backend through a Node.js framework. And in this backend folder, there is a shell script file. That shell script will make a task in the task scheduler, this which will open notepad for in the intervals of 5 minutes. So we'll just start the batch file with administrator access. So the website has been started now. As you can see, for example, this is a blog, maybe an article of something, and this is the fake captcha. This is the fake captcha website. So when I click verify here, we can see in this side of the page how this actually affects the victim systems. So first it will be profiling the victim, then it will make an initial beacon, session exfiltration, then the OS persistence and the payload retrieval. We can also see all the steps down here, how the victim is being profiled, how we send a C2 beacon, and how the exfiltration session happens, and how the task is being created in the browser security monitor, which can be seen in the task scheduler. So now we'll open the task scheduler just so we can check out how the task is being created. As you can see here in this tab, this is a browser security monitor. This has been triggered through this fake captcha website, and it will be triggered after 5 minutes, every 5 minutes indefinitely, which will open a notepad. This is a normal task which doesn't harm your system in any way. This is just a simulation on how the actual ClickFix activity would work. We can also check how the activity works, how it shows up on Wireshark for this demo. So before verifying it again, I'll just open Wireshark and we'll run Wireshark. So we'll run Wireshark to demonstrate this. We have started Wireshark. Now I'll go to the website again and I'll verify it. So the fake captcha refresh is done again. And after the attack stages, the task has been scheduled successfully. Now we can also go to Wireshark. and I'll pause it. So now when we go to statistics and to input output graphs, you can see spike. This spike right here shows the malware being installed in the system. We can also see this spike in the installed PCAP files of the original malware attack of KongTuke ClickFix activity, which I'll be showing you in a few moments. So there are total 20 inferences of the malware which I have covered in my blog as well. But due to the time limit of this video, I'll be only showing you one inst one I'll showing you one inferences from each of the attack stages. For example, one from initial click fix stage or captcha stage, one from post infection or download stage, one from secondary payload and C2 communication stage, one from TLS and encrypted malware traffic stage, one from system or geolocation profiling stage, and one from the final protocol distribution evidence stage. Alright, so I've already saved the commands for the display filters, so we'll be checking out this first. We'll be applying the TLS filter in the PCAP file here. TLS, press enter. Now as we can see, for the this filter, in this filter we have to search for uh, SNI ID in this info tab, which will show the URL frttsch.com. See, you can see it right here. There are multiple types of this, like you can see similar packets in this file as well, but we'll be just clicking the first one we found. So this is the one. All right. So you can see this PCAP packet contains a JavaScript file which is loaded from an unknown domain immediately after visiting the compromised site. From the actual KongTuke ClickFix activities, which was the compromised site. Now we'll be going on for the post-infection download stage of the attack. So we'll place the display filter and we'll press enter. So these are the two files, two packets which are being found out from this filter. We have to focus on the get filter because this is a get request from IP 144.31.221.71, which downloads a 25 MB malicious zip file, which is basically a Python package. The packet size is too large, so we'll follow the TCP stream. As you can see here, we have seen the TCP stream. You can see how a 25 MB file is being zip file is being downloaded, which is basically a Python package. Now we'll be checking out the secondary payload or the C2 communication stage of the malware attack. For this, we'll use the filter. We'll use this filter, which basically gives HTTP files and in which the URL contains the install report. So these are the full files we get. We have to basically check for the get get files again in the info. So this requests certain URL and from session based C2 check-in. So for this, we'll open any one of these get files. For example, this one. This is the request URL through which the report has been downloaded for the malware attack through for the C2 communication channel. Now we'll be checking the TLS or encrypted malware traffic stage. In this, we will apply the filter IP address with IP address 173.232.146.62. We'll get numerous number of files for this. So for what this basically is it's a multiple TLS connections to this IP, the IP address which I just applied in the filter, which is not a standard HTTPS port. It indicates that an encrypted C2 communication is using an outdated TLS version. So we can see that it's all using TLS version 1. So we can, to show this more properly, we can go to statistics tabs and see conversations. As you can see, there will be multiple packets in C5 going in through in a short duration of time. And so you can see the time duration here. See, the duration is very short for these 5 TCP packets which have been coming through for the C2 communication portal. Now we'll be going through the geolocation profiling stage. For this, we'll use the filter http.host contains IP info for the victim system. This will show us 3 files. So you can see the first file shows the city, second file shows the region, and third file shows the country. The third packet shows the country. These 3 packets show the city, region, and country. So these 3 sequential GET requests are made for the city, region, and country. the malware profiles the victim's physical location through these three parameters. And finally, we'll see the protocol distribution evidence, which will show exactly at which time the attack was being done. So in the statistic input output tab, we can see this graph is being generated for the TCP SYN packets and HTTP packets. In the a visible spike can be seen in these two timelines. These visible spikes are matching the blocks post-infection traffic log exactly as shown in the demo here. For all the other inferences of the malware, which I have just shown you the demo for, you can visit my blog. This blog covers all the necessary parts for the demo. We have also added an architecture diagram for the same. These are all the these are all the inferences. These are the inferences and the effects of the KongTuke ClickFix malware on your victim system, new findings from the work, and the conclusion. We'll be providing the YouTube link in the blog as well, and here's the GitHub repository. You can also check out the repository from the link I give in the description. These are the references, and I would like to thank Dr. Subbulakshmi from Scope Department in VIT Chennai for helping me create this demo and upload this blog on blogger.com and this demo video on YouTube. So thank you.